Bismillahirrahmanirrahim. Hello everybody. This is a new review about continuity of real functions. We start by f of x, which is equal to x squared minus 1 if x is irrational and 0 if x is rational. We know that q is dense in R and the complement of q is dense in R. This means that between every two rational number we can find an infinite numbers of irrational, and between two irrational numbers we can find an infinite number of rational elements. Or using another explanation, for all element x from R, we can find a sequence xn from Q such that xn converge to x0. And for all element x0 from R, we can find a sequence xn from the complement of Q, which is the irrational number, such that xn converge to x0. This means that if we consider x0 an element from R, this element can be a rational number and it can be an irrational number. Let us suppose for that x0 belongs to Q, which means rational number. Then there exists a sequence Rn, which is irrational, such that Rn converges to x0. In this case, we are discussing the continuity of f on rational domain. From the side we have f of x0. This is equal 0 by definition because it is a rational now. From the other side, f of Rn, from this side, f of Rn, this is equal to Rn squared minus 1. The square function is continuous, so this converges to x0 squared minus 1. So this converges to x0 squared minus 1. What do we have? We have the limit of f of Rn converge to x0 squared minus 1, but f of x0 is equal to 0. So our function is continuous just on 2 points. They should be equal, so x0 squared minus 1 equals 0. This means that x0 is equal to plus minus 1. So the rational elements on which this function is continuous is just plus and minus 1. How about irrational number? So in this time, let's consider x0 from the complement of Q, which means irrational. Since x0 is into QC, this means that f of x0, this is equal to x0 squared minus 1. This first, and the second remark, that x0 is in Q complement. This means that there exists Q from Q, the rational, such that Qn converges to x0. So from a side we have x0 squared minus 1, and from the other side we have f of qn, and by definition, this is equal to 0. They can be equal if and only if x0 square minus 1 is equal to 0, but in this case x0 square minus 1, since we suppose that x0 should belongs to the complement of c, this means that what? This means that x0 cannot be equal to x0 cannot be equal to plus minus 1, since this element aren't in a Q complement. As a conclusion, this function is continuous only. It is continuous only. They cannot be equal. Why? Because x0 is different of Q rational numbers. The conclusion is that this function is continuous only on plus and minus 1, just at these 2 points. How about this one? The same technique. It will give us that G is continuous just on x0, which are key in z. It is just continuous in these points. Out of these points, it is not continuous, it is discontinuous. Why? Because from a side it is equal to 0, and from the another side it is equal to sine the absolute value of x0. And since x0 is different of kp, so it cannot be equal to 0. I am sure that you have understand. Is this function continuous? The answer is yes. Why? Because if x0 is different of 1, this function is represented as power quotient and addition of continuous functions. I mean, the sine is continuous, the sine power 2 is continuous, x minus 1 is continuous, and since x minus 1 x is different of 1, this means that it is not equal to 0, and the quotient is continuous. But we have to discuss the continuity at just x0 equal to 1. We can remark that the limit of sine square pi x divided by x minus 1, when x goes to 1, this is equal to the limit of sine square pi x minus sine square pi divided by x minus 1 when x goes to 1. Because sine square of pi is equal to 0, so no change. And this is actually the derivative of the differentiable function, which is sine square pi x, the derivative applied at x equal to 1. This means that 2 sine pi x cosine pi x, and we take x equal to 1. This means that 2 sine 0 cosine minus 1, this is equal to 0. And since the limit is equal to 0 and it is equal to 0 when x is equal to 1, so this is a very continuous function. Thank you very much. See you next time.